Welcome all of you. My name is Rosalind Mishra and today I will be taking Pharmaceutical Organic Chemistry BP 202 code. Welcome to the MOOCs lecture arranged by Dr. APJ Abdul Kalam Technical University. So, we shall start with our unit Introduction to Carboxylic Acids. Well, this unit is divided into the following major parts. In the first part, we shall be dealing with aliphatic carboxylic acids, whereas in the second part, we shall be dealing with aliphatic amines. Under aliphatic carboxylic acids, there are various heads which we would be dealing with, so that at the end of this unit, all the students, all of you will be well versed about every details of carboxylic acids, starting from structure, starting from classification to preparation to their chemical properties, to their physical properties, etc. So, let us all begin. Now, carboxylic acid is a group of organic compound containing carboxylic group, which is the COOH group. Basically, it contains a C double bond O. It is a mixture of two components. In the name itself, we can divide them, which is carbonyl and hydroxyl. Combined together makes up the carboxyl group. Carbonyl, which is denoted by C double bond O, and hydroxyl, which is denoted by OH. This makes up the carboxyl group. It is a group of an organic compound containing carboxylic group. As I said, carboxylic acid contains carbonyl group to which the hydroxyl group is attached. A carbonyl group to which the hydroxyl group is attached. The general formula of carboxylic acid is RCOOH. RCOOH. In this formula, the R group denotes the attached functional group. It could be anything starting from an alkyl group, starting from an aromatic group, or any other functional group. So, R denotes the functional group. So, the major formula for the carboxylic acid is RCOOH, whereas I already told you all R means the functional group, C double bond O is the carbonyl part, OH is the hydroxyl part. The carboxyl functional group is represented as COOH and is the end product of alcohol oxidation. The term carboxylic acid is a little special in the sense that it represents two functional group as we have discussed earlier. First, a carbonyl group and second, a hydroxyl group. One can say that in the carboxyl group, a hydroxyl group is bonded to a carbonyl group. It is often represented as CO twice H or COOH. Carboxylic acids have been found to constitute one of the most frequently encountered class of organic compounds. A large number of natural products are either carboxylic acid derivatives or they are derived from them. The structure of the most stable conformation of formic acid is shown here. We shall be discussing it in detail. The entire molecule is approximately a planar molecule. Okay. So, here we can see the basic molecule of a carboxylic acid, which is formic acid, or the basic unit of a carboxylic acid, which is formic acid, which is HCOOH. From this molecule, we can observe clearly that it is a planar molecule. It is a planar compound. The entire molecule is sp2 hybridized. The carbonyl carbon is planar in nature. Hybridization, as I mentioned, is sp2 hybridized with nearly trigonal bond angles. The bond angles are trigonal in nature. The OH bond also lies in the same plane. The OH bond lies in the same plane, whereas the carbonyl bond is eclipsed here. The carbonyl bond is eclipsed here. So, this is the molecular structure of the most basic carboxylic acid, which is formic acid. You can see here the bond angle between the OH bond is 106 degrees, whereas the hydrogen and the oxygen bond is 111 degrees. The bond here is around 124 degrees, and between the carbonyl group is 125 degrees. Now, let us look into a few properties of carboxylic acids. Carboxylic acids dissociation in the presence of water to form carboxylate ion. So, if we look into the properties, then carboxylic acid when mixed with water or when dissolved in water dissociates. Okay. It dissociates to form carboxylate ion. It dissociates to form carboxylate ion along with one hydronium ion. So, when carboxylic acid is mixed with water, then two ions are dissociated from the one single acid, which is carboxylate ion and hydronium ion. The carboxylate ion formed is stabilized through resonance. This carboxylate ion formed is stabilized through resonance. So, here if we look into this reaction, carboxylic acid, which is R C double bond O OH, when dissolved in water, then dissociation happens. Dissociation happens. How? In the presence of water, hydronium ion is formed, which is H3O plus. In the presence of water, hydronium ion is formed, which is H3O plus, along with the removal of this hydrogen atom, making it RC double bond O, O minus, imparting a negative charge onto the carboxyl group, forming a carboxylate ion. This is the carboxylate ion. Okay. Where this carboxylate ion is resonance stabilized, that is, this double bond can shift between this oxygen and this oxygen. Okay. So, forming a resonance stabilized carboxylate group. This is the structure of the resonance stabilized carboxylate ion. Carboxylic acid exists as hydrogen bonded dimers. Okay. They exist as dimers. When two carboxylic acids are combined together, they form a dimer which is attached to each other via hydrogen bonding. So, these were a few properties of carboxylic acid. We shall look into these properties in detail in the further classes. Now, let us have a look into the preparations of carboxylic acids. How do we go about preparing carboxylic acids? Alright. Now, carboxylic acids are mainly prepared by the oxidation of a number of different functional groups. Okay. So, the first reaction under carboxylic acid which we shall be looking into is oxidation reaction. Okay. Now, oxidation of alkenes. Oxidation of alkenes. Alkenes are oxidized to acids by heating them with solutions of potassium permanganate, which is an oxidizing agent. either potassium permanganate is used as the oxidizing agent here, or potassium dichromate can also be substituted instead of potassium permanganate. Okay. So, oxidation reaction happens in the presence of an oxidizing agent like potassium dichromate or potassium permanganate. So, an alkene, for example, 2-pentene in the presence of potassium permanganate when heated leads to formation of ethanoic acid and propanoic acid. Okay, ethanoic acid and propanoic acid. So, a mixture of two acids are formed according to the number of alkyl groups. Okay, according to the number of alkyl groups, a mixture of two acids are formed. CH3, C double bond OH, which is ethanoic acid, and CH3, CH2, COOH, which is propanoic acid. So, when alkene like pentene undergo oxidation in the presence of oxidizing agents such as potassium permanganate and potassium dichromate, a mixture of carboxylic acid is derived, which is ethanoic acid and propanoic acid. Next, we will see another reaction wherein similar oxidation of alkene happens, but sans the oxidizing agents. Okay. The ozonolysis of alkene produces aldehydes that can easily be further oxidized to acids. Okay. So, alkenes undergo ozonolysis reaction to produce ethanoic acid and propanoic acid via the formation of aldehydes. That means, first an alkene is converted into an aldehyde. This aldehyde upon further oxidation gets converted into an acid. Okay. So, this is oxidation of alkenes. Here we have seen oxidation of alkenes using oxidizing reagents such as potassium permanganate and potassium dichromate, whereas in this reaction we have noticed oxidation of alkenes through the formation of aldehydes via ozonolysis. Next, another oxidation reaction wherein the substrate changes. Okay. So, instead of alkene, the substrate here is aldehydes, primary alcohols and aldehydes. The oxidation of primary alcohols leads to the formation of aldehydes. Okay. So, alcohols undergo oxidation to get converted into aldehydes. These aldehydes further undergo oxidation, or they are oxidized further to yield acids. Okay. So, all strong oxidizing agents such as potassium permanganate, potassium dichromate and chromium trioxide can easily oxidize the aldehydes that are formed. Okay. The thing which we need to remember here is mild oxidizing agents such as manganese dioxide and Tollens reagent are only strong enough to oxidize alcohols to aldehydes, but further oxidizing these aldehydes into acids is not possible by using these mild oxidizing agents. Okay. So, coming back to the oxidation reaction of primary alcohols and aldehydes. What happens here is, in the presence of strong oxidizing agents like potassium dichromate and potassium permanganate and chromium trioxides, alcohols are first converted into aldehydes. These aldehydes are further oxidized. these aldehydes are further oxidized into acids, But the catch here is the oxidizing agent has to be strong. In case the oxidizing agent is a mild oxidizing agent, then what happens is complete conversion does not take place. That is, alcohol gets converted into an aldehyde, but the further conversion of this aldehyde into acids is not possible. Okay. So, now let us look into this reaction. Here if we take for example a primary alcohol ethanol. Ethanol in the presence of an oxidizing agent like potassium permanganate, upon heating removes one molecule and water and hydrolysis leads to formation of ethanoic acid, wherein a C double bond O, OH is incorporated. Okay. That is, one hydrogen atom from here is removed, so that a C double bond O gets attached, and due to hydrolysis OH group attachment happens, so forming ethanoic acid. This as I explained to you all is a two-step process, wherein the first process aldehyde is produced. Okay. So, this will form a C double bond OH. Upon further reaction COOH gets formed. Okay. Similarly, ethanol. So, here all of you have seen how ethanol in the presence of a strong oxidizing agent is getting converted into ethanoic acid or a carboxylic acid. The next reaction is oxidation of alkyl benzenes. Okay. So, oxidation of alkyl benzenes. Alkyl group that contain benzylic hydrogens or hydrogens on a carbon alpha to a benzene ring undergoes oxidation to produce acids in the presence of strong oxidizing agent. Okay. So, I repeat again. Under this oxidation of alkyl benzene, what happens is oxidation of alkyl groups or the alkyl groups that contain benzylic hydrogen or a carbon atom on alpha hydrogen, alpha to a benzene ring, carbon atom alpha to a benzene ring undergo oxidation in the presence of strong oxidizing agents to produce corresponding acids. Okay. So, now let us take for example propyl benzene. Propyl benzene in the presence of strong oxidizing agent undergo oxidation to produce benzoic acid. Okay. To produce benzoic acid. This takes place in the presence of heat and corresponding hydrolysis. The next reaction, isopropyl benzene also gets converted into, as I told you all, the carbon atom alpha to the benzene ring. Okay. So, similarly, isopropyl benzene also in the presence of potassium permanganate, that is a strong oxidizing agent, has the tendency to get converted into benzoic acid, yani corresponding carboxylic acid. This carbon atom gets converted into the acidic group. Similarly, tertiary butyl benzene, the alpha carbon to the benzene ring reacts in the presence of a strong oxidizing agent under high temperature, does not produce any reaction. Okay. Because here the alpha carbon atom does not exist. Okay. So, no reaction is seen in the case of tertiary butyl benzene due to absence of this hydrogen atom, In the above example, as I have just told you all, tertiary butyl benzene does not contain a benzylic hydrogen. This does not contain a benzylic hydrogen and therefore does not undergo oxidation reaction. Okay. So, absence of benzylic hydrogen, here, as you can see here, there is no hydrogen atom attached on this carbon. So, absence of this benzylic hydrogen leads to non-reactivity of tertiary butyl benzene. Non-reactivity of tertiary butyl benzene. Okay. So, this is how oxidation of alkyl benzene, yani alkyl group that contains benzylic hydrogens or hydrogens on a carbon alpha to the benzene ring undergo oxidation to form the corresponding carboxylic acids only in the presence of strong oxidizing agent. Okay. So, under this case we have seen 3 reactions wherein propyl benzene undergo oxidation, it did underwent oxidation and got converted into benzoic acid. Similarly, isopropyl benzene underwent oxidation reaction due to the presence of this benzylic hydrogen atom. Due to the presence of benzylic hydrogen atom, isopropyl benzene underwent oxidation reaction in the presence of potassium permanganate and upon heating to form benzoic acid. In the third case, due to the lack of this benzylic hydrogen, there was no reaction seen. Now, moving on to the next preparation of carboxylic acids, wherein the starting material is a nitrile. Okay. So, nitriles undergo hydrolysis. What are nitriles? Before going into the reactions involving nitriles, let us just understand what these groups are. What are these organic compounds? See, nitriles are organic molecules containing a cyano group. Okay. So, a C triple bond N group or a cyano group. So, the hydrolysis of nitriles, which are organic molecules containing a cyano group, leads to formation of carboxylic acids. These hydrolysis reactions can take place in either acidic condition or basic condition. So, for the conversion of nitriles into acids, the condition required could be either acidic condition or basic condition. Okay. So, propan nitrile here in this case CH3, CH2, C triple bond N. Propan nitrile in the presence of heat, or when heated, gets converted into CH3, CH2, C double bond OH. Okay. So, hydrolysis of this cyano group takes place such that instead of C triple bond N, C double bond OH gets formed, or a carboxylic acid group is formed. Similarly, benzonitriles, when we look into benzonitriles, here the reaction is almost similar, only the R group changes. Okay. So, nitriles reacts or undergo hydrolysis in the presence of heat. If we go about writing the general reaction, then nitriles, this R group can be alkyl group, this can be an aromatic ring, it can be any functional group, to form an acid which is RC double bond OOH. Okay. So, this is the general formula for the preparation of acids from nitriles, wherein hydrolysis of nitrile takes place. So, here if we see benzonitrile in the presence of heat undergo hydrolysis and in basic condition to form benzoic acid. So, the product formed here is a benzoic acid. The R functional group remains same. Okay. The nitrile group undergo hydrolysis to form a carboxylic acid or RC double bond OOH, RCOOH. The next reaction is, or carboxylic acids can also be prepared via carbonation of Grignard reagent. Okay. So, these carboxylic acids can also be prepared via carbonation of Grignard reagent. Grignard reagents react with carbon dioxide to yield acids, salts, which upon acidification produce carboxylic acids. Okay. So, R Mgx, where R is an alkyl group, this is the magnesium atom group, these are the halogens. So, RMgx is the Grignard reagent. They react with carbon dioxide to yield acid salts, which upon further acidification produce carboxylic acids. So, here if we see phenyl magnesium bromide, this is the R and this is the magnesium and this is the halogen or the X. So, phenyl magnesium bromide upon hydrolysis in the presence of carbon dioxide forms benzoic acid. So, this was the final reaction under preparation of carboxylic acids. Let us look into the uses. On many available uses of carboxylic acids, few of them are listed below. The fatty acids that are essential to human beings are carboxylic acids. Carboxylic acids, for example, omega 6 fatty acids, omega 3 fatty acids are a few of them. Also, the higher fatty acids are used in soap manufacturing. The production of many food products and soft drinks involve the use of various carboxylic acids. The rubber manufacturing involves the use of acetic acid as a coagulant. Hexene dioic acid is used for nylon manufacturing. Carboxylic acids, for example, ethylene diamine tetraacetic acid is a very commonly used chelating agent. Many drug synthesis also involves the use of these compounds. For example, in the preparation of pharmaceuticals, the production of several polymers involve the use of carboxyl compounds contained in the functional group. These are the reference. So, with this we finish our topic today, wherein we have discussed about carboxylic acids and their preparations. Thank you.